All right. Well, I guess we'll start then. So we have with us now Daniel,
Hello.
who is a postdoc at the University of Sheffield and also working in part at the AMRC, if that's right.
Yeah.
Um, I guess we start at the beginning then. What was I think originally your bachelor's, your undergraduate degree was engineering focused, right?
hmm
Can you
Yeah.
tell us a little bit about what you did, maybe your final project? Uh,
Mm, Yeah. So I did my bachelor's degree in Spain. I did mechanical engineering.
mhm.
Uh, my last year was specialized in construction engineering, but I did my final year project on alloy development. I did work with research center and ArcelorMittal to create an alloy that was used for windmills power shafts.
Oh,
So we tried to move away from proper steels into these kind of cast irons because they are easier to cast and they are lighter as well. If you engineer the bainite and the actual graphite on it to be globular, you can get really nice mechanical properties and fatigue performance. And as well, you can get the graphite to be as a self-lubricant mechanism to improve the wear resistance as well. It was a project pushed by this steel company to make also train crossings because they have similar kind of fatigue and wear resistance. So when you change, for example, the gauge of your rail from standard gauge in Europe, Spain has a different standard for the normal train, so you need to change it at the border, and those things get really under lots of fatigue when they change the gauge. So yeah,
so
that was basically my alloy development for that. That was my
that's a
final year
super
project.
materials focused project for an engineering degree. Is that kind of what transitioned you into material science for your PhD, or was
Well,
that more of a apply for
it was the
PhDs and see what you
no,
get?
not really. I really wanted to do some metallurgy. Uh, I think the way you so I really like designing and I really like engineering and structures and mechanisms. But if you think about that, the main bottleneck for making those designs being manufactured is that you need to get some materials to make them,
Yeah,
and developing new materials are the very bare design enablers in technology and of course engineering to make those things work.
absolutely. Yeah,
So yeah, probably I was more interested into enabling technology for others to get their ideas working more than getting ideas and get bogged down into, oh, I want this to float or I want this to be this way, but there's no material to do that. So I thought that probably if I want to make a nice contribution with an engineering degree to not just science but to manufacturing or to society in its own, was probably developing new alloys or new materials.
is
And
that
yeah, that
that
was
sort of
probably
desire to contribute what pushed
yeah.
you towards your PhD choice? Because obviously, whilst you've done a master's in more of an engineering style, you could potentially just go into a
Mhm.
job afterwards.
Well, when I was doing my degree, the actual situation of the economy in Spain wasn't fantastic.
No, wow.
I do understand that. Well, of course, the ideal situation would have been just to get my degree, get a position near my hometown, get a nice salary, and that's it, and sign the contract and be happy. But I felt like um, that wasn't going to be the case, and that's normally not the case even in the best case scenario. So to be realistic, I felt like I needed to improve my CV and get a much a higher level education but than a normal degree. So that's why I decided to do a master's in science, because I was interested into characterizing materials. I was very interested into the alloy development and manufacturing of things, and I
Hmm.
felt like because I was a mechanical engineer, I knew a lot about design and processes, but I had no idea about the very first part of the process, which is materials selection and materials design. And that was kind of my idea of trying to, how to say, improve my employability somehow. Saying,
Yeah,
look, I don't know
widen your
about
skill set.
processes. Yes, and now I know about also the materials that you need to use, so I can improve my designs or my processing techniques or whatever based on the materials that I already know how they are made and how they behave.
Yeah, exactly. So if you take us then to the next step, like with all of that in mind, like what did you do your PhD on? If you have the engineering in mind and you were looking at potentially alloy development and such, was that what your PhD was about?
Not really. Well, before
In
that,
part?
you need to understand why I went to a PhD. So my first idea was to get my widen skill set and go back to Spain and get a job. However, when I finished my master's, the economy was still the same. The actual requirement from the Spanish industry of highly qualified engineers wasn't actually quite interesting in terms of not just job opportunities but also salaries. And the problem is that even if I were to go back at that moment and get a job, it wouldn't have had any impact in any process at all. I would be just like a process control, the process monitoring, the steel industry, for example. So I got to a point where I said, well, if I really want to make this kind of design enablers and this kind of changes with my degree and my knowledge and now the master's, probably going into research might be a nice way of contributing to that. Not just contributing because of any publications, which I'm not really into publicating, and I'm very centered into the things that I do, create job opportunities to people who really can make great things. So I think in my case would be going into a PhD because it was a nice opportunity to get into research with a company, with a manufacturing company, and somehow fulfill also my engineering interest, not just science, in terms of I'm doing science with an application, with a focus into solving a problem, which is probably why I think doing a PhD this way was the right way for moving forward.
Yeah. What was the content then primarily of the PhD that you did?
So
if you could give us the elevator pitch, kind of.
Yeah, at the moment when I started my PhD, the actual aerospace industry was booming like we've never seen before. We were expecting to get twice as much planes flying in the next 20 years. So the manufacturing processes, and specifically the very critical aerospace part, had to be manufactured as fast as possible, the highest quality achievable. And they knew how to make them quite good, but they didn't know how to make them quite fast. And one of the issues that they had is that their manufacturing processes weren't updated because of that fear of the saying, now it works, I don't want to move it because I don't know how changing those manufacturing processes and parameters would affect the component. So if now they don't break, just don't change anything. Just buy more machines, put more manufacturing lines, and keep the manufacturing rate as constant as possible. The manufacturing rate as constant as possible. The problem comes with my PhD was trying to link how the manufacturing process actually affects the fatigue life of these kind of critical titanium components, and then after understanding the actual mechanisms, the crack initiation, crack formation, etc., go back to the planning stage into the manufacturing line and say, now you need to do this and you need to do that as an engineer, because we know the material science behind it, and now you can make things faster while keeping the quality.
Cool.
Yeah, that sounds really cool. Actually, I didn't know it to that extent. And you managed that within a lot less time than a PhD usually takes.
Yeah, I mean, if you sleep less time, you have more time to work.
But you did finish early, didn't you, Danny? And how early compared to like the standard sort of 4 years of the CDT that you're on?
So I started on September 2016. I did finish writing my thesis on December 2019, and then that is
it's almost a year ahead of time.
That looks like that, but you get Brexit in the middle. You need to get a job. You need to get your indefinite leave to remain if you want to keep the country, and at least the type, or at least being able to get a proper job in the same, let's say, leveling the field with the rest of the graduates from the UK. And I felt like I needed to at least pursue a job. It could be in academia, or it could be in something. So I it was easier for me to apply for the settlement status and demonstrate that I was doing something for the economy, rather than just saying I was a student for 5 years. Just please, pretty please, give me your settlement status.
I mean, it may have been a matter of circumstance, but it's still very impressive that you managed to get it all done so quickly.
Well, I think also because my family is not here, I am not spending time with my family, and as much as I wanted, of course. And even if I were living next to them, I wouldn't be spending as much time as I want with them anyway. But I think that's also an important variable to consider. That, for example, during summer, I used to spend probably 2 weeks with them instead of 3 months. I mean, I'm not saying people do that, but I'm saying that myself, if I were there and my job would have, let's say in a hypothetical case when I was in Spain and my job gives the opportunity to be with my family for 1 month or for 2 months, I would have done that. But due to the way I'm living here and my parents living there and the rest of my family living there, it's not as easy as, I mean, I have more spare time during the summer period, let's say, and winter time as well.
So would you say then that people doing PhDs have to sort of work that, or do you think that was just a more of a personal matter of circumstance that you decided on yourself?
It's a personal circumstance. It's not just my decision, it's the way it is, to be honest.
One of the benefits, you can work as hard as you want during your PhD, as long as you can get things done early. If you work harder, if you choose to work harder and sacrifice
yes,
time.
I do. Yeah. It's a sacrifice I didn't have to do because I'm already living here. Yeah. But I reckon if my parents were from Sheffield, for example, or from Manchester, whatever, things would have been much different. But that doesn't mean what I did was what everybody should be doing, or if it's good or not. I'm just saying that the circumstances I had is not the same for everyone. I guess your PhD is your own project. You can enjoy it from different angles, and I choose to do that. I'm not saying you should be doing differently or the same. Just
no, absolutely. Yeah, it's a very personal thing, your PhD and your project, because it's your own work and you're responsible for it. So, yeah.
And for any undergraduates who kind of are thinking about doing a PhD, how would you kind of convince them that a PhD was a good thing? Like, what is the best part did you find about doing a PhD?
Or the worst part?
Or the worst part, both.
Okay, I think the best part is flexibility, and I think that sometimes that works for any research position, specifically in not. I'm not saying like in the private sector, but probably in a research facility or even the university. For example, if tomorrow I don't turn up for work, nobody will come at me and say, "Hey, you should be typing today, or you should be pressing the spacebar today." But having said that, you need to get a mindset where you know what you're doing and you have your own soft and hard deadlines that you need to impose on yourself, because it's not like a normal job where you will get a boss pointing at you doing, I need that for Tuesday, or I need that for next month. And I think that's probably a mindset that most of the people might not have. So I would probably consider very, very cautiously to get into a PhD if you don't have that mindset. However, I think that there's a lot of people who that aren't choosing the PhD at the moment, that they are in the industry and probably not happy because they are just part of a very large system and not doing not making any difference actually in anything they are doing. So I think the best could be the flexibility. The worst is that you need to make sure that you are independent enough to deliver what you consider has to be deliverable, and I think that requires a level of maturity, if that's a way of saying that. Maybe most of the undergrads might not have, or may not know that they have it.
Yeah. Do you think that's something then that is part of, if we're kind of bizarrely part of the skill set that you develop during the PhD, is that you can go into it maybe as not quite the level that you are you're saying there, and you can develop that over the PhD as you learn sort of how to live and work in that kind of an environment?
Well, I think so, yeah. I think that kind of skill set that you develop in your PhD, if everything goes all right, I think it's quite valuable. It doesn't have to be just in academia or in the private sector. I think for life on its own, the situation where you need to do you have your own problems and you need to solve them. Nobody is going to come and say, well, this is how you do it, don't worry, that's it, fantastic, you don't need to do it anymore. You need to solve your own problems, you need to set your own goals, and that means that, yes, you don't have someone to dictate what you have to do, but at the same time you need to have some kind of inner force or something or driving force to help you achieve something. And the interesting part is that thing that you need to achieve, it's not written in stone, but what it's written in stone, or at least I see it like that, or in a contract, is that you need to achieve something useful, something that could support basic science, that may not have anything related with engineering, or anything that might have like a use in everyday life, or maybe solving a problem that is very linked to industry, which is what I did, what I feel more comfortable with, but not like this kind of a skill set of solving your own problems. I think that's the most valuable part of a PhD, rather than me knowing that an atom is oriented in a certain direction, I will break or not. To be honest, I do feel like that.
Yeah, I find that quite interesting, because solving your own problems is something that I wanted to learn by coming into a PhD, because I went into a company and I just did the same job again and again and again and again, and I wasn't really making that much of a difference, and I was always just doing what I was told to do, and I felt like I hadn't ever really learnt the skill of figuring out how to do your own work. It was one of the ones that I was like, well, I'm going to go and see if I can do a PhD, because I need to learn these skills if I'm going to get anywhere in this industry.
Yeah, and I think those kind of values are very appreciated also in the private sector, because most of the people go into a job and they go up in the hierarchy of the company, and they don't have that kind of base skill to solve the problem, so they end up repeating what the previous person did. And at some point, someone had that kind of skill and they developed the system, and that's it. And that's how it goes. And sometimes you even end up with an inverted cone system where everybody's managing and they don't know what they're doing, and there's only one or two or a team of 3 people that literally solve all the problems. And when they are gone, the company, it's a very serious
lost
trouble.
Its support, it collapses.
Yeah.
Wow. Yeah, I think that's probably quite a good take on it. Really, I like that. If we can then maybe take it back to what you're doing at the moment, then you're postdocing. So after they developed this skill set and used it to get a job in a field somewhere, maybe they choose postdocing. So what is it that you're doing as a postdoc at the moment? I know your situation's a little unique, but maybe what do you do at the moment? What's particularly interesting about the area? What do you get to do in your time? Is it all still research like it was in the PhD? Yeah,
I think so. It's a different type of research, I guess, at least in my side. I am very lucky, because in my position, nobody tells me what I have to do. Most postdocs, you join to a program and then they tell you, well, these are the deliverables. You need to figure that out. How are you going to tell me if this is good or bad, or how are you going to join this with that, or how are you going to mix this with that and then make it whatever other thing. And that's kind of an open project, but you still have to be bounded to that. In my case, I'm still bound with some deliverables, but I kind of set up my own deliverables in terms of the type of achievements that I want to get. I mean, of course, there's like a great goal, which is in the manufacturing sector. The idea is to develop a system that can manufacture components, specifically machining, but could be forging, could be anything, that takes the information from the material, and instead of looking at, let's say, tool life of how long an insert takes to wear off, or something like that, some kind of engineering variable to consider, we think, or at least I think, that we need to consider how the microstructure of the component defines the actual processing parameters. Not just thinking about, I have this, which has a very rubbish microstructure, and I need to manufacture in that way to make it much better. But then that new microstructure that I have, how that will define the next processing parameters, or the next heat treatment, the next forging, the next machining part, etc., etc. So in order to get to that point, we need to develop not just destructive techniques to analyze and see how that component behaves, but we need to create somehow a digital twin of the component to know what is going to be the expected microstructure and the expected behavior of the machining, and finally the expected fatigue performance, dual fatigue, etc., from the information that we get from every single manufacturing stage. And the problem is that if we use destructive analysis at the end, we don't have reliable information because we just destroyed a component and we don't know how. Of course, it's broken in half.
You need to test a new component to know if that has the same microstructure as one you've just tested.
Yeah, and then you end up with a million components broken and no parts manufactured. So what I do at the moment is using novel approaches to gather that information without having to destroy the component, or without having to manufacture something equivalent that then we test. Then we consider that the component that it's next to it will behave as it should, and try to apply that to different fields, really, not just aerospace, which is probably the most important at the moment because they put a lot of money in, but also biomaterials and orthopedics. Because if a component, if a military plane breaks in half, that's pretty bad. But if somehow the hip implants start breaking a lot, that's pretty bad as well. And I do think
risky
that,
surgery, hip replacements.
And I do think that is where you make a change. So if I know the microstructure and I know how to manufacture it right, and I can make a person have an orthopedic implant and not having to be, operated 3 times in its lifetime but only 1, that for me it's a huge change, and that makes my work valuable, rather than, for example, making lots of money because I can produce something 3 times cheaper.
Well, I mean, it also does, if you could do it without these destructive tests, it would theoretically drive the cost down and make hip replacements like that more accessible to people who need them. So it's also like kind of a double hit of beneficial there. So that does sound good.
If we get some kind of traceability for every single component, and we can reduce the discarding rate to 0, that means that the actual price per part will go down, the quality per part will go much higher. And then in the case of an argument between different suppliers or different manufacturing stages of where things went wrong, because you have the traceability, once something goes wrong, it doesn't go to the next stage, so you are reducing the probability to failure of that component once it is installed into a jet engine or installed into a person to 0. Which is the one of the main driving forces, because at the end you get other variables that will define how you want to achieve something. So in the case of the hip implants, for example, you can't only operate someone into the femoral stem 3 times in a lifetime, because then you get some issues with the hydroxyapatite and this kind of stuff. It's not pleasant, but it doesn't really grow the bone as good after you've done it a few times. So that means that person will have to go in a wheelchair, and that's because probably not poor engineering, but using our knowledge of materials and engineering, we can make that change and have that impact very soon. It's not something that will change probably the next 20, 30 years. That's something that could be adopted by companies right now and make the change now for the next people who's going to get operated. So that's probably a difference thing, and that will probably link with the type of research that you do. So in my case, my TRL levels, technological readiness levels, mine are quite high compared to, not high because it's better, but high because it's less fundamental science, more applied science.
It could just be sort of plug and play almost.
That's the idea. So people know how microstructure changes, people know how to forge things, so now we get all those things together and we make it available for industry. And that's the type of research as well. It's not just I know how things forge, now I know how to solve all the problems. No, you need people to get that information and get it across design a process, and that's why I think being an engineer is quite convenient in this kind of analysis, and then just move it forward. That doesn't mean it's your own invention. That doesn't mean you are solving the problem. You're using the information from other people's research to improve quality of life in that kind of example.
Is that something that you think is more something that you see in postdoc positions over PhDs, in this sort of combining research rather than?
No, I don't think so.
You've just really sort of gotten yourself into a position where you've got a postdocing position which is just followed through with your work, which is quite...
Well, I do think I've never done any fundamental science, to be honest, which sounds horrible when you think about doing a PhD and not doing any fundamental science. But I'm quite happy about that. I do embrace it. I think it's a different type of research. I know postdocs that do very fundamental science and look at atoms, and they look at cracks and crystallography and TM, and they go to ICIS and they do diffractions and stuff, neutron diffractions. And that's also a valid postdoc position. I think it's just being a postdoc, it means doing more research and having to deliver the deliverables of your project. It is similar to a PhD. Well, you got more responsibility because it's not your project anymore. You are employed. It means that you need to probably, I don't know, it depends on the position. I need to talk to many people from different backgrounds. I need to talk to technicians. I need to talk to engineers. I need to talk to scientists. I need to talk to physicists, mathematicians. I need to talk to even the people who make the machines. I work with CNC machines, with the people who make that, and I go like, oh, I am a doctor or something. They go like, yeah, whatever, sciencey, blah, blah. And they go, yeah, but I'm a mechanical engineer. I know this is a linear actuator, and this goes like that, and you have this kind of encoder. And they are like, okay, so you are not a typical PhD student. I'm like, no. It's not like I'm not or I am. It's just the conception of the people who think that doctors do very fundamental science. We don't. That's it. Or we may. But there's lots of people who don't. And that's probably one of the conceptions of people who try, undergrads that want to start a PhD.
Might turn some people away.
Yes. It's like, I don't want to look at atoms. I want to, race cars and rockets and satellites and, I don't know, medical science, drug deliveries, and lots of people doing PhD in medicine, in all this kind of...
they are working in those fields.
They're working in those fields, yeah.
You need doctors in all kinds of backgrounds, or PhDs maybe in all kinds of backgrounds to sort of push.
And I'm just talking STM, but other fields as well are quite applicable to that. So,
you're in terms of that. Then, are you going to be looking to stay in research as a job, as keep postdocing, or are you going to, do you think, transition to an industry research position at some point? Like, because obviously this is something that we've, I think, in these discussions talked about before. In the lecturing position at a university is more luck than skill. You need to be in the right place at the right time. So, what's your sort of thoughts on that as sort of your future plans then for?
Well.
Obviously, it can be vague. I'm not asking you to have like a 5-year plan set up.
Just going to be honest at the moment. I really like doing things. And I really like knowing who knows how to do things, so I can do things with them.
Yeah.
I wouldn't mind teaching, but I do think teaching has to be done by someone who really wants to do teaching. Because the quality of teaching is defined by someone who has the values and the capabilities, the human capabilities to do teaching. I might be able to do teaching, no problem, and maybe do a living in teaching. But I do think there's much value. I would do a much bigger impact in other type of field than teaching. I'm not saying I wouldn't be able to do it. Most of my family are teachers and professors, so I'm like the black sheep. But I think you need certain type of human skills that I might not have. Having said that, I would rather transition into more research than academic, more industry-led research. But that doesn't mean that I will be disconnected from publishing, for example, or from people working at the university. I think the world needs people who are with one step in proper research, very fundamental science, and then new ideas coming up, and then the industry applying them. I think there is a gap in there that has to be filled. It's like a niche, and I think it's not a small niche. I think it's a very important niche. I think the universities, sometimes they are like bubbles. The companies are like bubbles, and there's no connection. Companies cannot thrive because they don't get new technology. Universities cannot research because they don't get money for doing research, but the industry has the money. I think there is a gap in there, and I would like to see myself in filling part of that gap by bridging production and new great ideas that sometimes they get published, and that's it. And in the academic world, they are very happy because they get all the citations, but they don't change people's lives. You just print 10 very colorful graphs from a paper, and that's it. And I don't think that's the end of research. I think publishing is fine as long as you can share what you do, but sharing doesn't have to be in an index journal. It could be a talk with your friends. It could be in the pub. It could be talking to someone who you know who works for someone. That's why I say knowing what people do better than me, so I can work with them to show them how we can do things together better. And take advantage of that. And I think that's probably very, very linked to what you said about lectureship. I know probably getting a lecture, being a lecturer and getting one position like that, you need to be in the right time, in the right position. My advice would be, instead of being bogged down into getting to somewhere, I will be always trying to keep all the options open. Try to know people, try to understand what people do, so you can then have more information to decide on what you want to do. So it could be very interesting to be, very academic and very nice, have very nice laboratories, look at the atoms floating in the air, or I don't know. Or it could be very interesting as well, being like large slabs of metal being squashed in half a second. That's very interesting as well. But if you know what people do in every single field, then you can decide what to do and where you can make a bigger impact, or where you can be more comfortable doing your job. So I think that would be probably my view on that. It's not just trying to pursue something, it's to get as much information as possible to make the right decision at the right time. And yeah, sometimes maybe you are planning into doing something in the industry, and maybe someone comes and say, hey, I want you to be the lecturer, to be a lecturer. And then at that moment, you might think, well, that's probably a very nice way of doing that. You can always stop being a lecturer. It doesn't mean that you are clamped on that. When I started my PhD, I never thought I was nailed onto that position and then nailed into being a postdoc and nailed into that. I think that's a very that's a very important mindset to have. Like, you're not a public employee or something like that. You're not nailed to that position. You could always change. Get your skill set as updated as possible in the fields that you are interested in, to be able to sell yourself and be able to find your niche or create your niche.
So much helpful advice there. A lot, because I think a lot of PhD students feel like, oh, I'm going to be stuck now. I'm going to be stuck doing academia stuff,
or even they don't think about it. They just kind of assume that they're going to move into a postdoc position.
It's a self-fulfilling prophecy. Yeah, exactly.
Yeah.
So I think that what you need to do is flip it on you. At least that's what I do. Flip it into your favor. So instead of thinking, oh God, I'm in academia, I'm going to end up in academia. I wanted to be in the industry 3-4 years ago. Now I'm nailed to the academia. Just make it the other way around. It's like, what do I need to do to keep all my options open? Yeah. Academics need to think that you publish, that you have a really nice, high quality research, and that you are an independent researcher that can get to the deliverables of the project and be able to apply for grants. And industrialists need to know, well, you're not just a doctor, you're literally a person who can come here and solve my problems, so you're a problem solver. So the industry is not interested into knowing why an atom is moving around. They just really want to know why the things go wrong. Yeah, mm-hmm. So they just want, look, you have the skills to just solve this problem as soon as possible. That's it. The academia is more like, you need to understand all the basics. So if you understand all the basics, you can solve the problem. It's the same problem all the time. At least I see it like that. If you got the skill set and you know the basics, you can be an academic and choose to be an academic. Or you can go into the industry and solve all the problems because you already know the basics. It's just this is the same skill set. It's just flip it on your own, on your favor.
Whichever way you prefer, right?
Yeah, it's like easy.
Yeah, it's like that's one of the things I never realized until I sit down and I look at the things you do. So you know so many things, but the most important value is that once we finish a PhD, it's like you get your brain like a baby. It sounds horrible, but it's like very moldable, and you can change your skills quite quickly. And then you just go and I need to learn to program, and then you learn Python because you are so used to the pressure that, by the way, you put on yourself. But I know about that because I put a lot of pressure on myself. But this is the most important thing. It doesn't really matter what you did on your PhD. You have a set of skills that are quite valuable because not a lot of people have them. I know people who work in Forge in all their lives, and they work. They know how to operate that machine, and that's it. If that machine disappears, it's like yeah. If a computer comes and does that job, that's it. You need to consider yourselves as someone who, regardless of where they work, you are very difficult to replace, because all the information that you've captured and all the values, not values, but values skills. As well. Skills, yeah. It's very difficult to get into someone's mind. Very difficult. I always tell people when they talk to me, well, we need someone who knows about computers and knows about pathology. And I say, get a PhD. Why? Because you can tell a metallurgist how to code something, but you can tell a computer scientist in 3 months how to do metallurgy.
Yeah.
You know, so I'm not saying it's different. I mean, computer scientists, they do other things and they have other types of research. But for the kind of work that we try to do, you'd rather know the basics and then improve your skill set and use it as a tool, like programming, rather than making your living through coding. Because if not, you wouldn't be doing metallurgy. You would be doing other stuff. You would be a developer. You would be, looking at software improvements, type of calculations and maths and stuff to make things faster. So I think that's probably the most valuable point. The skill sets that you have, it's very broad and it's very difficult to find people with that skill set. It's transferable as well. Yeah.
So, if you're a PhD then, and you're looking to gather these skills, and you want to do that in an area of interest in the field, what's your, and this is very personal opinion, right? I'm not pointing at you as some kind of industry savant here. What's your opinion on some of the more interesting aspects in material science at the moment that people might want to focus their sort of transferable skill sets in towards? Do you think, because with the current situation and everything, perhaps airlines production isn't necessarily going to be one of those major drivers of money in industry and research? So where else do you think could people find inspiration?
I am an experimentalist 100%. I need to do things with my hands. If not, I feel like doing nothing. If I don't see like things appearing in front of me, like chunks of metal or whatever, I feel like I'm doing nothing. Like, oh yes, I did like 1,000,000 lines of code. Yeah, okay. I think probably modeling might be very interesting, but not just modeling for the sake of modeling and getting nice graphs. That will be quite interesting. For example, I would say as well, having very, very important, I wouldn't say very important, but being very confident when talking about things to people who doesn't have the same background as you, trying to find yourself in the middle point. There's lots of people who might have a concept of your position before you approach them. So being approachable is very important. You need to be like a coin with two sides. You need to be the expert, the person who knows how to solve the problem, but at the same time, someone who can just go and pick and say, well, you need to explain that to the operator and not be very bogged down into, scientist, blah, blah, blah. And I think that's very important. I think that's one of the most important ones. If people can understand, if you can change your pitch and choose the right words to talk to a person, that person will be very, very much high likely to help you and to work in the same direction as you, than if they have this kind of preconception of you that you will be, oh, I am the doctor and you are the operator. You need to do this because I am the doctor. And that doesn't make any sense because you will end up doing nothing. So I think that kind of transferable, different type of pitch way of talking gives you into a very malleable position where you are very versatile. And I think versatility might be the word to that. That's more important than characterization techniques, than TM, that whatever thing you want to learn. I think that's the most important one.
What you're to just consolidate that, you're saying that people should realistically go for PhDs in whatever they're interested in and just try and generate these transferable skill sets within the areas that they're interested in, and then they can use those to pivot and keep as many options open as possible from that position, rather than necessarily thinking 10 years in advance, I want to be here, and then pushing very single-mindedly in that line. You think that's
Yeah, I think pushing single-mindedly on anything is bad. It is very weird to keep your expectations and your life plans aligned with a very rigid expectation in a long period of time. That will end up with frustration, and that's pretty bad. And that happens with projects, with life, with anything. If you have an expectations and you don't get to that, it's frustrating. If you start setting up your expectations 10 years ahead and you don't even know what's going to happen in 3 years or in 3 months, it is very difficult to achieve that. And then maybe in 10 years, you don't want that either. So you've been working for 3 years or for 5 years to get into a position where you think it's rubbish and you would rather do pottery. Yeah, so I think having as many doors open and options open, it's the most important part. And consider the PhD into training.
A door opening thing, right? You want to get your fingers in as many doors as possible for kind of future potential. Yeah,
in a PhD you are assessed on your capabilities and the things you learn. You're not supposed to be an expert on everything you've done in your PhD once you finish. You've just started what you've. It's like a training program to be a researcher.
That's
People think like, oh God, I'm a doctor in metallurgy. I need to know about everything. What does hafnium do in the steels? I have no idea. I machine titanium. That's it.
That's another very good point. I think that people are sometimes, I think, intimidated by the idea of doing a PhD because they think they've got this time limit in which they need to become
masters of the universe.
Some kind of master of their field. But it's really it's the starting point of a career in research or work in that field, right? It's not something necessarily to be afraid of in advance. And
no, I don't think so.
Yeah. Okay. Just I suppose finish off then. We can transition to some more sort of less serious, more sort of interesting stuff. So how about where's the coolest conference? Because that's something that people used to be able to go and do in PhDs. Where's the coolest conference that you've ever been to, Danny, in your time research?
Back when they were a thing.
Back when
I had a really nice time in San Diego. I have a really nice time in February. It was sunny, and it was in February 2020, to be honest. Believe it or not. Yeah, but I had a really nice in Budapest.
What conference was the San Diego one?
TMS. The mineral-metallurgical, something like that. So many M's society. Yeah. What
was so cool about that? Was it just the weather and the location, or
I think
was the conference itself like?
Yeah, it was quite broad, so you could literally, there were so many rooms where you could pick wherever you want to look at, and because there were so many rooms, it's very likely to find someone who's in your niche. So just go and check those things out, and because it's a very large conference, lots of people from lots of countries will come that you maybe can't not access, but they maybe didn't publish what they are presenting, or maybe you don't know that they have a research group. They do that, and that's how you meet people from lots of places, actually. But yeah, the location was fantastic. Let's be let's be honest.
And what did you do when you weren't at the conference?
Ooh,
Yeah, what do researchers get up to off hours?
eat so many tacos I couldn't count.
Tacos.
Tacos, yeah. No,
Famous San Diego cuisine.
Yeah, no kidding. I think probably I do like visiting museums and places that I wouldn't be able to go normally because of time constraints, or because they are bloody expensive, or because it's just you're there and I feel like kind of obliged of looking at these nice sites. So I think that probably sightseeing is the most important one. But yeah, definitely eating lots of tacos and going to the beach as well. And yeah, enjoying the sun in February. Yeah.
Yeah, going outside and
Oh yeah, doing nice outdoor sports in February because it's freezing here.
Sorry, yeah, apologies for our weather there, Danny.
No. I'm from the north of Spain. It's like with Yorkshire weather. So when I go to summer places, where they have like a proper summer, or they have proper weather, I really enjoy being outside and doing exercise and go running and swimming and stuff. It's just a nice way of spending time outside, to be honest.
Okay. Well, thanks for coming along, joining us in the call, Danny, and asking questions. Do you have anything you wanna say or sort of promote for? It's fine if you don't, but
cheers, guys. I think it's quite interesting to talk about these topics normally.
Yeah, because
you don't talk about those things in work. You just talk to other people about your project, what you really need to do, and sometimes, and even now that we are working from home, we don't have this kind of 4 p.m. on a Friday where you go to the pub and then you talk for an hour about stuff that doesn't have to be work. I think that's very important as well, and part of the social life of the PhD, apart from doing the PhD in itself. So this kind of social life, it's kind of missing. I'm missing it, of course, but I think it's very important as well to make very nice bonds with different research groups and different people that could benefit from each other from the things they do.
Okay. Well, thanks for coming again, Danny, and good luck with your research.
Yeah, good luck to you guys. Cheers.
Thank you.
Thanks a lot for having me. Yeah.